Hello everyone, so we will be seeing how we can actually solve a second order differential equation in C++. The strategy will be to use the Euler Integration Method, and how we are going to use this Euler Integration Method is basically we will convert this second order equation into the two first order equation. So the equation is ax double dot plus bx dot plus c is equal to 0. So a, b, c are basically our constant. So what we will do is basically x double dot, and this whole side of equation we will take onto the left hand side, and then we will convert into the first order equation as v is equal to x dot, and similarly v dot basically will become our 1 when we shift this equation to the left hand side. So this is how we will be doing. So these two equations we will be writing it in the Euler integration form. So when we write it in here, x is equal to x plus x dot into dt, which is nothing but dx by dt. Similarly for the v we will be doing like this, and this is how these are the two equations basically which we were doing. One, this x new and the v new. So that is basically the conclusion we can make, that the first order differential equation, it is being converted to, and now we will be solving it numerically in the C++ code.
Second order equation solved and how we can plot it in our CPP, as we have already discussed in our PPT. So here I will just write the equation as we have already discussed. So the equation is ax double dot, so I will be writing d dot plus x double dot plus b into x dot plus c is equal to 0. C into x, basically c into x is equal to 0, and so here also I will be writing this. Okay, so now we are good to go. So now first we will be describing our header files. Include iOS string, and then using namespace std, and then also we have to save our file, so we will be writing it as abstract include fstring, because we will be solving it in our header file. So now we will be writing the main body. So now what we have to do is, as we have defined a, b and c are our constant, so first we will be defining our constant. So this is our step 1. So this we will be using again double a. So a will be our 1.0 I am taking, double b is equal to 0.5 I will take, and then double c is equal to 20. So this is what I will be taking it our constant, and similarly we will be doing what is basically initializing the time constant. So basically t and tt, so till how much time we have to run the simulation, so that we will be writing as t max, which will be our 10 seconds. And then similarly we will be taking the unit, because we will be using the Euler's integration formula, numerical method. So in that we will be using this guy, so this we will be using. And then similarly now we have to also describe, so now we will be describing our for loop. So for double t is equal to 0, t is less than equal to t max, because we have to run till 10 seconds. So now this will be t is equal to 0 is equal to dt. So this is how we will be writing. And now here describe our loops in which, so first we will save the things which will be coming. So this is for the saving of the file. So file, so first is the time, and then first is the time, and then we will be saving our x, So what we had described was x dot basically becomes the v, and this x d dot will be the v dot. So what we will do is, so x dot is the, if we integrate it becomes x, so that will be plotting and x dot will be plotting. So the whole intention was first order, second order becomes the first order. Second order differential equation will be converted to the first order. So this is how we'll be writing. So this is the x variable, and this we will be plotting our first order differential, and then so as we have done it in here. So before we have to write here to save the file, we'll be writing it here as file dot of string. I will be writing here as mass dot dat, mass1 dot dat I will write, and then yeah, so this is done. Oh yeah, I made a mistake. So it will basically file of stream dot file. So this I will be writing. Sorry, not dot. So now this is correct. And now similarly we will have to go. So now we have not defined the x and v basically. So we will also define here our x and v. And x and v. So double x is equal to 0.01 and double v is equal to 0.0. So these are our initial guesses. We will be writing, and so this will be our x and v. So now we will be going forward, and then we will be writing here our main equations, what we intend to plot. So here will be our x, v. So derivatives we will be writing. Double x dot is equal to v, and double v dot is equal to, so v dot is basically our x d dot. So as we had seen in the our PPT, so that we have to write in here. So it will become as minus b into v minus c into x divided by a. So this is how we will be writing, and now we will be writing the Euler integration form. Is basically nothing but x is equal to x plus x dot into dt, which we have already discussed, and similarly we will be writing for the v as v plus v dot into dt. So the first thing, let's just check we have written C out or not. Okay, C out is important, and similarly we will be writing in here as we forward the semicolon. Okay, so now we will be writing in here as file dot close, because we have to save this guy out, and then return 0. This is what we will be doing. And now Control S. So you have already written. Let's just run this file up.
Let's just see if the outputs we are getting or not. So G++ rd11.cpp we'll be writing in here, enter, hit tab. So this is we have got. So mass1.dat you should be able to see. So mass1.dat, these are the values, so these are the coordinates basically. So now what we are doing, we have to since plot, so I will be writing in here as the GNU commands to plot. So GNU commands to plot. So here what I will do is I will put the hashtag, so it will put the comment part. So what I will do is first I will write the address which I have saved. So I have saved this guy up in here. So Control C, and here I will be writing as CD, Control V. So now change those hashtags. So yeah, this is good to go, and then we'll be writing as set x label. I will be writing as display. This I will be writing as time, and set y label as I will be writing it as displacement, just for my understanding. So I will be writing as meter, and then I will be writing as set title distance versus displacement versus time, and then set grid. And now comes the main part, plot mass1.dat, and then using 1:2 with lines to title xt we will be writing in here. So yeah, so let's do this thing, Control C, and then I will go with the GNU Plot. So let's copy this, and this thing is there. Okay, so let's now copy this guy up, Control C, and then now let's press enter. Yeah, so we have got the graph. So this is how we can get the displacement part of it, meters, and we can change those constant and just play around with those graphs. So this, when you move the cursor, you can just see the x and y value of it, and you can make the sense out of it. So yeah, this is how we will be plotting this thing, the second order differential equation. So thank you for watching. Bye.
Like, share, and subscribe. And have the power